since we're already familiar with the concept of temperature and volume, let's talk about pressure of a gas a little bit in more detail because that's the one that you're probably least familiar with. So traditional measurement of gas pressure uses a column of mercury. So what I have illustrated here is a diagram for what a barometer looks like. So this is a barometer, and we use it to measure the pressure of the air around us. So it measures atmospheric pressure. Okay, so you have a pool of mercury right here, liquid mercury. Remember, mercury is one of only two elements that exist as liquids under ordinary conditions. And what you have in your pool of mercury, you have a tube that's inverted. So this is sealed, okay? And up here, you have a vacuum. That means no molecules there. No air, no nothing, okay? And if you invert that vacuum into this pool of mercury, what happens is the air will push that mercury up the column. And typically, this height that will be supported by the atmosphere would be around 760 millimeters or 76 centimeters, typically, approximately, depending on where you are, depending on what the weather condition is. Okay, so like there's a storm coming, you hear the expression, the barometer is falling. What that really means is that level of mercury in your barometer is dropping. So your atmospheric pressure, we say, or your barometric pressure is dropping. So since at sea level, that's typically around 760 millimeters, we have defined a unit for pressure of a gas to be in terms of the height of the mercury column that it would support. So 1 atmosphere, okay, ATM is abbreviation for atmosphere, it's a unit of pressure, is defined to be exactly 760 millimeters mercury. Okay? Now, when we're talking about atmospheric pressure, it's somewhere around 760 millimeters mercury. It's not exactly 760 millimeters mercury. The unit 1 atmosphere is defined to be exactly 760 millimeters of mercury. So to avoid confusion, let's just say if we want to refer to atmospheric pressure, okay, when we're referring to the actual atmospheric pressure, it's preferable to refer to it as the barometric pressure. So that you don't confuse it with the 1 atmosphere pressure, which is defined to be exactly 760 millimeters of mercury. Okay? So what if you have a gas, a sample of a gas in an enclosed container like this one right here? Well, what you use to measure the pressure of that gas, remember we said we use a barometer to measure the pressure of the air around us, right? And you have a pool of mercury that's just open to the atmosphere. Well, if you have a gas that's in a container, then you hook it up to a U-shaped tube like this. This is called a manometer. And this particular type of manometer is closed end. When we say it's closed end, what we're referring to is this part right here is sealed, okay? And what you have in here is a vacuum. And pretty much it works just like a barometer, except that this side right here is not exposed to the atmosphere, so it's only exposed to the gas. So the height of the mercury column between the two arms of your manometer, so this side right here and this side right here, that height difference, okay, that would be, you can measure that in millimeters or centimeters. That height difference would be that's the pressure due to the column of mercury, okay, and that would be the pressure of the gas. So the height of the column of mercury, the difference in the height between the side that's hooked up to the gas and the side that's under vacuum, would be that difference in the height of mercury would be the pressure of the gas. And the unit for the pressure of the gas would be a unit of length of mercury. So it's either millimeters of mercury or centimeters of mercury or meters of mercury. The most common ones you use is millimeters and centimeters. Okay? And a millimeter of mercury, by the way, is also known as 1 torr. Okay, in honor of Torricelli, who invented the barometer. Okay, that barometer I illustrated earlier is called a Torricelli barometer. Next question here. Here's another way you can measure the pressure of a gas. You can use what's called an open-end manometer. And the difference between that and the closed-end manometer is this part right here, this side, is open to the atmosphere. Okay? So one side is open to the gas, is connected to the gas. The other side is open to the atmosphere. So here you have two possible scenarios. Here, the one on the left, okay, you'll notice the one on the left, the mercury level is lower on the gas side compared to the atmospheric side. So on the atmospheric side, the one that's open to the atmosphere, the pressure is P bar. Bar meaning barometric, right? So what we're saying here, okay, think of it this way. If you have two people pushing on this column right here, who's pushing it harder? The gas or the atmosphere? The gas is pushing harder than the atmosphere. So we say that the pressure of the gas here would be higher than the barometric pressure. Okay? So this difference in the height of the mercury columns, this height right here and that height right there, the difference in the height, let's call that H. Okay, that's the difference between the barometric pressure and the pressure of the gas. So since the gas is higher, you add H to the barometric pressure to get the pressure of the gas. Okay? Now on the other side, in this scenario over here, which one is pushing harder? The air outside or the gas? The air outside. So you have to subtract H from the barometric pressure to get the pressure of the gas. So right, this one right here, the difference in these two levels is H. Okay? So let's look at an example here. What's the pressure of the gas in the manometer, in the figure illustrated in the manometer? In the manometer that's illustrated in the figure here. So the right arm, this is the right arm right here, is open to the atmosphere. Okay? And you have your gas right here. Can you estimate the pressure of the gas for me? Pressure of the gas is going to be equal to, is it higher or lower than the barometric pressure? Lower, because your air is pushing harder than the gas. So you subtract the height. What's our height here? 55 centimeters of mercury. Okay, that's assuming we have mercury in there. Okay, from the barometric pressure. Okay, do we know what the barometric pressure is? We don't, but we can approximate it. So if you want an approximation here, what's a barometric pressure typically? 760 millimeters of mercury, right? So in centimeters, that would be 76 centimeters of mercury. So if you don't know what it is, it's not given to you, but you know that you're exposed to the atmosphere, then you can estimate the barometric pressure to be about 1 atmosphere or 76 centimeters of mercury or 760 millimeters of mercury. So 76 minus 55, and so what's our pressure of a gas here? That would be 21, approximately 21 centimeters of mercury. What would that be in millimeters of mercury? 210 millimeters of mercury. What would it be in torr? Also 210 torr.